Why can a CNC machine cut metal so precisely that parts fit together like they were grown, not made, while the whole machine is literally shaking from cutting forces? Short answer: precision is a feedback game. A CNC doesn't guess where the tool is, it constantly measures position, corrects errors, and compensates for the real world. Example: if you need a slot within plus or minus 0.01 millimeters, that's about a human hair's thickness. It's not one trick. It's a system. First, tolerance is the allowed mistake. Not perfection, permission. And it's different from accuracy and repeatability. Accuracy is hitting the target. Repeatability is hitting the same spot again and again. CNC magic is mostly repeatability, plus smart calibration. It starts in CAD and CAM. The software turns geometry into tool paths, then into commands, move X, Y, Z like a choreographed dance. But the machine doesn't move in millimeters. It moves in steps and counts, tiny increments driven by motors, screws, or linear drives. Here's the core: closed-loop control. Encoders measure where each axis actually is, thousands of times per second. If the command says, "Go there," and the encoder says, "Not yet," the controller pushes harder. If it overshoots, it corrects back. That loop is why CNC feels almost alive. Precision also comes from brute stiffness. A rigid frame, preloaded bearings, tight linear guides, because cutting metal is like pushing a knife through wood while someone tries to shove your hand sideways. If the machine flexes, your perfect toolpath becomes fiction. The enemies are mostly invisible: tool deflection, your end mill bends microscopically under load. Runout: if the tool isn't perfectly centered, it cuts slightly wider every revolution. Backlash: tiny slop in drive mechanics that shows up when direction reverses. Good machines fight these with preloaded ball screws, tight spindles, and compensation. Then there's heat. Metal expands. Machines warm up. Even the spindle grows a little as it runs. High-precision shops warm the machine, control the room temperature, use coolant strategically, and apply thermal compensation so morning parts match afternoon parts. CNC precision isn't only cutting, it's measuring. A touch probe can tap the stock to find exact zero. A tool setter can measure tool length. The controller stores offsets, tiny corrections that account for tool wear, tool changes, and real part position. So the program stays the same, but reality gets updated. And finally, strategy. You don't cut to final size in one aggressive pass. You rough fast, leaving a small, consistent margin. Then you do a finishing pass with stable forces and smoother motion. Less force means less bending, less vibration, and cleaner dimensions. So CNC precision isn't one miracle, it's feedback control, rigidity, compensation, measurement, and smart cutting strategy working together. Now I'm curious, if you had to pick one to improve, machine stiffness, better probing, or thermal control, what would give the biggest jump in accuracy, and why?